Do you guys feel like your life is a little upside down right now? Yeah, me too. But just know that my expectation of you all is just that you try your best. Make sure that you are communicating with me. If you have any issue, both with the math or just with the technology, make sure that you're communicating. And then just enjoy the fact that this is a new experience. Something to learn from, both the math and otherwise. So I think we will all learn a lot from it. But today is finally the day that we get to do some math. I know you're excited about that. I'm excited. We're going to start our trig chapter with degrees and radians. So before we get started here, go ahead and get out some paper, something to write with. Treat this like you would sitting in class. You wouldn't be listening to me teaching and not take notes. And you definitely wouldn't ignore me. You wouldn't be able to. So don't do that. Give yourself a little bit of structure. Take notes like you were sitting in class. That's going to help you stay focused when we're going through these videos as well. We're going to start by drawing a circle. I hope you brought your compass home with you. I know I did. No, I'm just kidding. You can freehand it. Just do your best here. That's going to be the anthem of distance learning. Do your best. Go ahead and draw yourself a circle. If you have a ruler with you, you might grab a ruler as well, or a straight edge, just so that it's not all wonky, but you can freehand that as well. No judgment here. I'm not gonna be able to see your notes. But go ahead and draw in like an X and a Y axis, a vertical and a horizontal line, and we're gonna get started here with degrees, which is something that is a lot more familiar to us. We use degrees a ton in geometry and just everyday life. I think it's a little bit more common to talk about. So when we're looking at this circle, the place that we start, we are going to kind of treat it like a coordinate plane where this is quadrant 1. So our starting place, or 0 degrees, is going to be on that x-axis right there. If we go all the way around the circle, we know if you turn all the way around, you've gone 360 degrees. Technically, as many times as you want to go around this circle. If you want to go 720 degrees, that's going to put you in the same position. So we could keep going around, but we're just going to talk about those angles in between 0 and 360. So up here, if we've gone this right angle, we've gone 90 degrees, another 90 degrees, and we're at 180, another 90 degrees, and we're at 270. Okay, so with our straight edge, we're going to add in the most popular of the angles, the most beloved. So with your straight edge, go ahead and draw a segment halfway in between 0 and 90, and then draw it all the way through. We're going to use the other side of that as well. And then same thing in between 90 and 180. Okay, so since these are halfway in between, like our first one is halfway in between 0 and 90, these are all going to be 45 degrees from the x-axis. So this first one is 45 degrees. But then 45 degrees from 90 is going to put us at 135. 45 degrees from 180 gives us our 225. And then 45 degrees from our 270 gives us our 315. All right. Now we're going to go in between 0 and 45 degrees, but it's going to be closer to the 45. These are going to be our but it's going to be closer to the 45. These are our 30 degree reference angles, so 30 degrees from 0. Same thing in between 135 and 180, but closer to the 135, all the way through for both of those. So we're looking at being 30 degrees from 0, or any of these being 30 degrees from that x-axis. So if we're at 180 and we travel 30 degrees up, we're at 150. Or 30 degrees down is our 210. And then our last one, 30 degrees from that 360, is going to be 330. Okay, last angles. This one is going to be in between 45 and 90, but closer to the 45. And these are going to be our 60 degree reference angles. Same thing on the other side, closest to the 135. So from 0, this is 60 degrees from 0. 60 degrees from 180 is going to give us our 120. 60 degrees on the other side is going to give us 240. Oh, hello. And then 60 degrees from our 300 is going to give it, or 360 is going to give us 300. Okay, so these are all of the main degrees that we're going to be looking at, which I think you all are pretty familiar with, but I think it helps just to visualize where each of these are in our circle as we head to radians. So when we're talking degrees, and I actually drew this earlier, we've got a really tiny sliver that would be like 1 degree. If we're trying to visualize what's happening with our degrees and our radians, our radian is about 57 degrees. So 1 radian would be like this angle right here. Okay. So it's much larger. So it's just like if you're converting from inches to feet, sometimes it's easier to talk about inches. Maybe we're talking about something small. Sometimes it's easier to talk about feet. Usually we don't give like the height of something pretty tall in inches. That would be kind of silly. So same thing with degrees and radians. There are certain times when it makes sense to use radians, and we're really, after this lesson, going to strictly use radians from here on out. So very important that we can connect the two things in our minds. Something that you may remember from Honors Algebra 3 is that radians use pi a lot, and the fact that a whole circle, it is going to still be 0 radians, just like it was 0 degrees, but it also is going to be 2 pi in radians. And that's what makes radians a lot more useful in areas than degrees, because we can use pi and that makes them easier to use, a little bit more versatile. So if our whole circle is 2 pi, that means that half of our circle would be pi. That means that 90 degrees would be half of that, so 0 to pi, so you'd have pi over 2. Our 270 would be halfway in between pi and 2 pi, so it's going to be a 3 pi over 2, or you can think of it as like 1.5 pi. But after that, we get kind of stuck. We kind of go through those, but then if it's not a 90-degree angle, what do we do with that? So if we're going to convert from degrees to radians, we're going to look at some examples here. And after we go through these, you really should be working to memorize them, but we're going to go through how you would convert them if you didn't have it memorized. So anytime we're converting from unit measure to a different unit, so perhaps inches to feet, then I'm just going to use a unit ratio. So for example, say I had 14 inches and I was wanting to know how many feet that was. I would just multiply it by the unit ratio that relates inches and feet. So I would say that my 1 foot was equal to 12 inches. I always want to make sure that my units are across from each other, because then they're going to cancel. And then I would get that my 14 inches is 14 over 12 feet. So similar thing happening with our degrees. For example 1, if we're looking at 30 degrees, I want to use a unit ratio, and the easiest one to use is the fact that 180 degrees is going to be equal to pi radians. So just the way that I use my 1 feet to 12 inches, I'm going to come over here and say that my pi radians is the same as 180 degrees. I always want to have my degrees across from each other, radians across from each other if they're there. And then I can cross cancel. That makes this a little bit easier. Usually there's something I can divide them both by, and in this case I can divide them both by 30. And then multiply across to get my pi over 6. So that is pi over 6. Okay, with 150, same thing. It's going to be the same thing with all of the converting from degrees to radians. I'm always multiplying by that same unit ratio, my pi over 180. Similar thing happens on this one. I can divide them both by 30, and I get my 5 pi over 6. So that was the 150. Notice that we could have determined that this 5 pi over 6 was in the second quadrant just by the fact that my 5/6 is greater than 1/2 but less than 1. So kind of ignoring the pi part, but just the fraction out in front of it. If I know my fraction is greater than 1/2, but less than 1, it has to be in that quadrant. And then our last one here, still multiplying by the same unit ratio, but for this one, a little trickier. I can still cross cancel, but anytime I have something that's a little different here, I can probably divide by 45 degrees. We just have those common angles that continue to happen throughout this. So if I divide them both by 45, I'm going to get 7 and 4. That's going to tell me that my 315 is my 7 pi over 4. Okay, so go ahead and pause the video and try some of these on your own. Go ahead and try 45, 60, try a few of these, and just make sure that you are understanding how to convert them, but I'm going to go ahead and write them all in so that you can check if you need to. So there are all of the radians for the main angles.